Life is a very rare phenomenon in our universe. For it to emerge and develop, there must be many factors: perfect temperature, water, important chemical elements, and atmosphere. Life on Earth is here because of the combination of all these factors, but it can't exist forever on one planet. Astronomical scientists right now are continuing to look for and study distant exoplanets, which can not only tell us more about the mysteries of the universe, but could also possibly become our home in the future. Today, we'll tell you about the exoplanet most similar to Earth, and whether they could be suitable for our life. The first planet on the list is K2-18b. It's a mysterious planet 8 times the size of Earth, and located 124 light-years away. K2-18b orbits the red dwarf K2-18, which is about 1.5 times cooler than the Sun. The planet is very close to its star, the distance between its orbit and the star being about 13 million miles, or 2,100 kilometers. So, 1 year on, it takes only 33 days. Despite this, its average surface temperature is 17 degrees Fahrenheit, which is slightly warmer than on Earth. In addition, because of this proximity to the star, the planet is probably experiencing wave blocking, so only one side of it is facing the star. However, according to scientists, K2-18b is in the habitable zone, meaning the temperature there should probably be balanced, which could mean there could be water on the planet. Almost 80% of dwarf stars have planets in the habitable zone. Perhaps scientists should focus on the study of such planetary systems to have a better understanding of the mechanisms of their development, therefore, to establish how life is possible on such planets. Moreover, thanks to the enormous brightness of the star, astronomers have been able to detect the planet and even give it a very complete description, despite the considerable distance. Usually, red dwarfs are dim and very difficult to detect, but K12-18 could probably be quite active. However, this in turn may hint at very strong irritation of the planet's surface. Nevertheless, the planet's enormous size worries scientists somewhat. As researchers know the mass and size of the planet, they can establish its density. The established density of the exoplanet is intermediate between the density of Earth and Neptune. Therefore, at this point, it's impossible to say for sure whether the planet is a super-Earth, a mini-Neptune, or even a fully aqueous world. The rocky planet scenario seems more likely because of Earth's more characteristic atmosphere. But the minor helium envelope, with the considerable mass of the planet's core, makes it look like Neptune or Uranus. Still, many scientists view K2-18b as a rocky super-Earth, so we'll do the same. Now, let's look at the atmosphere of an exoplanet. In 2019, a team of researchers at the University College London, researchers found water vapor in the atmosphere of an exoplanet. Therefore, if K2-18b is still more like Earth, there might be water. In addition, the water vapor molecule may indicate the presence of hydrogen and helium. Moreover, scientists believe that the layers of an exoplanet's atmosphere may even contain methane and nitrogen, important for the emergence of life. Also, due to the probable presence of water vapor, the planet may form clouds, which also hints at the high metallicity of the atmosphere and, among other things, speaks in favor of the habitability of many Neptunians. And yes, if the planet is fixed in a wavelock, then the clouds can only appear at the terminator, the dividing line between the hot and cold sides. On the other hand, a group of researchers led by Marcus Shu suggests that K2-18b has only a hydrogen-helium atmosphere. It may not contain water at all, so it can hardly even be an ice planet. Still, despite many contradictions, K2-18b could be habitable. The planet's temperature and pressure, provided it has a solid surface and a metallic core, could probably be favorable for the development of life, albeit presumably extreme. Nevertheless, the planet requires a more detailed study to assess. the potential for the emergence of Earth-like life there more precisely. The next massive planet, ELS 1140b, already has a confirmed solid surface. ELS 1140b is 40 light-years away from Earth. The exoplanet is 7 times larger than Earth and also orbits a very small red dwarf, about 10 times smaller than the Sun. In addition to ELS 1140b, there is another rocky planet in the planetary system, ELS 1140c, slightly larger than Venus. ELS 1140c orbits at a distance of only 2.5 million miles, or 4 million kilometers, and therefore is not in the habitable zone like ELS 1140b. The exoplanet also has a fairly short orbital period. It only takes 25 days to make a complete revolution around the star. Nevertheless, despite its proximity to the star, the planet receives half as much light as Earth does from the Sun. Moreover, it's also likely to be tidally blocked, so only one side is fully heated. The temperature on the illuminated side of the exoplanet is -36 degrees Fahrenheit. In addition, perhaps the proximity to the dwarf could indicate strong irritation of the planet. Oddly enough, the star's UV radiation is at an extremely low level. Therefore, the UV fluxes probably cannot do much harm to possible life there. Despite the low temperature, this probably does not prevent the existence of a probable internal ocean on the planet. The weak radiation from the star is unlikely to cause a loss of water from the surface and atmosphere on ELS 1140b. Moreover, according to a study led by Jason Dittman, the planet may have had magma oceans. At some point in its evolution, that could have replenished it with water. Another group of scientists believes that ELS 1140b and ELS 1140c may have formed outside water before migrating to their current orbits, thus the presence of water on this planet may be very likely. The exact composition of the atmosphere of ELS 1140b is unknown. A group of scientists, led by a team of researchers, believe it may contain water vapor and a small amount of hydrogen. However, another study suggests that the exoplanet's atmosphere may have a thin layer rich in hydrogen. So there could be ammonia, which fertilizes the Earth by increasing the oxygen content of the atmosphere, and methane. Nevertheless, in such atmospheres, oxygen and ozone molecules are actively destroyed. Still, several more transit observations are needed to accurately determine the composition. ELS 1140b currently meets many criteria for a favorable development of life. So we have to wait for new results of one of the most promising exoplanet. Thank you. Kepler 452b is probably the Kepler telescope's most famous find, and officially nicknamed Earth 2.0. This planet orbits in the habitable zone around the star Kepler 452. Very similar to our Sun in size, temperature, and brightness, 1,400 light-years away. Kepler 452b is probably 5 times the size of Earth, and has a radius half the size of our planet. Therefore, it takes about 385 days for the exoplanet to completely bypass the star. The average surface temperature of the planet reaches 17 degrees Fahrenheit. The enormous distance between us and the exoplanet makes it impossible to know for sure if it's rocky. NASA researcher John Jenkins and researcher Jing Chen believe it's unlikely to be Earth-like in composition and could be a mini Neptune. What's interesting is scientists even took several years to test whether Kepler 452b really exists. It was discovered in 2014 during a Kepler Science Operations Center test. Although it had previously been undetected for years due to equipment errors. Because of doubts about its existence, scientists rechecked the data for several years before finally confirming the planet in 2016. Nevertheless, the question of the habitability of Kepler 452b remains open. According to astronomer Douglas Caldwell, the planet has enough gravity to support water and a biosphere. Moreover, because of its long habitable zone, it may contain all the necessary chemical elements for the origin of life. Moreover, according to Jenkins, there may even be plants that can synthesize oxygen just as we do. However, there is one problem that may cast doubt on the development of life on an exoplanet: its star. Kepler 452 is older than our Sun, so it's about a bit brighter than our Sun. In addition, Kepler 452b receives 10% more sunlight than Earth. Since the exoplanet is even larger than Earth, it could be exposed to high temperatures. This means that Kepler 452b could have a very strong greenhouse effect, causing all the water to boil off, making the surface hotter. Therefore, the distant exoplanet may already be a fading world, rather than a thriving one. Kepler 452b cannot be accurately analyzed because of its gigantic distance, nor can we truly determine whether we could live there. Although, on the other hand, the discovery of an older planet with a similar star to ours will help us learn more about what may await us in the distant future. Another exoplanet recently discovered by the Kepler telescope could probably be habitable. It's planet Kepler 1649c, which is much closer than the previous exoplanet, namely 300 light-years from Earth. It orbits a red dwarf 1.5 times colder than the Sun at a short distance, making a complete revolution in only 19 days, so it's probably blocked by tides. In addition, Kepler 1649c, unlike all previous exoplanets, has almost no different mass and radius from Earth. Because of this, and also the fact that the planet receives 75% of its star's light, its surface temperature may be the same as ours. This makes Kepler 1649c the first closest exoplanet to Earth in both size and temperature. Therefore, it's possible that liquid water could exist on the planet. It's now difficult to establish whether Kepler 1649c is a rocky planet, but it's considered very likely. It's also not yet known whether the exoplanet has an atmosphere. What is interesting, scientists have discovered one oddity. In addition to Kepler 1649c, the planetary system probably has another planet, Kepler 1649b, which is very close to the star. Usually, the planets in such systems enter into strong resonances, usually 1 to 2 or 2 to 3, to create internal stability, that is, one revolution of one planet is equal to 2 revolutions of the other. However, these two planets have a 9:4 resonance. Such a ratio is very rare if not unique. A pair of planets in this case is very stable, which means it will last a very long time. On the other hand, there may be another planet in between, which creates a chain of resonances. So far, it's difficult to say whether Kepler 1649c is habitable because of the very limited data. Perhaps if the current James Webb Telescope turns its attention to a distant planet, we'll then be able to say more about its viability. Kepler 186f is one of the Kepler 186 planets orbiting in the habitable zone. The Kepler 186 planetary system is 580 light-years away and has 5 confirmed planets larger than our Earth. All of these exoplanets have a number beginning with Kepler 186b and ending with an F. The system's exoplanet, with the exception of the F1s, are too close to their star, a cold red dwarf, so their habitability is probably unlikely. Kepler 186f is about 1.5 times larger than Earth, and also has a larger radius, but its orbital period is only 130 days. In addition, because of its distance from the central star, the exoplanet can orbit around its axis without experiencing wave blocking and thus distribute temperature more evenly across its surface. Moreover, Kepler 186f probably receives a 32% lower stellar irradiation dose than Earth. But because the planet is in the habitable zone, even though its radiation energy is low, it can collect and store liquid water. But what is the composition of Kepler 186f? It's not yet possible to establish that. However, scientists suggest that for this planet, so far, there are 3 scenarios of how its composition may be: consisting entirely of water or ice, consisting entirely of iron, and having the same composition as Earth, that is, 1/3 of debris and 2/3 rock. Also, presumably, the atmosphere of the exoplanet is unlikely to contain much hydrogen. It could, moreover, have a helium-hydrogen cover, but the UV exposure of the star could have almost completely destroyed it. Nevertheless, the planet is still considered potentially habitable. According to the simulation team of scientists led by Emmeline Beaumont, organisms could develop on Kepler 186f if it is still rocky and has an atmosphere consisting of water vapor, nitrogen, and carbon dioxide. Interestingly, the researchers also believe that oxygen photosynthesis, though less productive, is possible on the planet if it is rocky. The last exoplanet on our list found by Kepler is Kepler 62f. This planet, like the previous one, is located in the habitable zone of the 62 planetary system, 1,000 light-years away. The central star is generally similar to the Sun, but differs in size and slightly in temperature. It's about 3 times smaller than our star, and its temperature is about 8,410 degrees Fahrenheit, when the Sun's temperature would measure up at 9,940 degrees Fahrenheit. There's also 5 major planets orbiting the star, and 2 of those, Kepler 62f and Kepler 62e, are at the limit of habitability. Kepler 62f is a more likely candidate for the development of life than 62e because the latter is at the very edge of the zone. It's been suggested that it could probably be a mini Neptune and experience a strong greenhouse effect, almost completely ruling out life there. On the other hand, Kepler 62f is deep in the habitable zone. Therefore, it may not be blocked by tides, but it's also slightly heated by the star, receiving about as much light as Mars. Nevertheless, established data regarding its size, the exoplanet is 1.5 times the size of Earth, and its orbital period of 267 days may suggest a planet probably has water and a very promising candidate for habitable plants. Interestingly, according to research, Kepler 62f may even have the same seasons as ours, as hinted at by its axial tilt. Moreover, the exoplanet could hypothetically have a satellite to stabilize its tilt. The composition of Kepler 62f remains uncertain. However, as in the case of Kepler 186f, it's very likely that it could be rocky. Still, to support life, it needs to have an atmosphere 3 to 5 times denser than Earth. It must contain several times more carbon dioxide to remain warm and contain liquid water. Therefore, only further observations will answer whether Kepler 62f is inhabited. Music. The next planet, already a little closer to us, 48 light-years away, is called Gliese 1214b. In the case of this planet, scientists are very confident that it may not be rocky at all, but completely watery. The exoplanet orbits a red dwarf, and is currently the only planet detected in the system. Gliese 1214b is about 8 times more massive than Earth, and has twice its radius. However, it's much smaller than ice giants like Neptune, so it's classified as a super-Earth. Also, the planet spins just 1.2 million miles from its star, making a complete revolution in 38 hours. So the temperature of the exoplanet's surface is very high, ranging from 248 degrees Fahrenheit to 539 degrees Fahrenheit. But then, could organisms like those on Earth exist on Gliese 1214b? Let's take a look at the data we now know. Please, Gliese 1214b most likely consists almost entirely of water, including the core. However, it's still difficult to say for sure whether Gliese 1214b is an oceanic planet or a mini Neptune. Also, theoretically, 5% of the planet's mass is the atmosphere. The upper layers of the water planet are probably covered by clouds. So it's difficult for scientists to accurately determine the chemical composition of the planet and its atmosphere. However, according to the studies of the spectra of exoplanet, their atmosphere may be dominated by water vapor, which can be explained by the active evaporation of water or hydrogen. In addition, the atmosphere has recently been found to contain helium. Initially, the presence of this gas as a component of the primordial atmosphere was excluded. The presence of helium could not only tell scientists more about the evolution and development of such planets, but could also contribute to the formation of an atmosphere with high metallicity, that is, with the content of elements heavier than hydrogen and helium. On the other hand, researcher Leslie Rogers suggests that there are several scenarios of what Gliese 1214b could have originally been to get such a dense gas envelope. For example, it could have been entirely rocky with volcanic activity that filled the atmosphere, or a gas ice stone planet with a metallic core, silicate mantle, layer of water ice, and gas that trapped helium and hydrogen during its early formation. Nevertheless, the planet's still full of mysteries for astronomers. LISA 1214b is very promising in terms of habitability, so we'll wait for new information about it. The next interesting planetary system is Teegarden. The central star of this system is a red dwarf, nearly 10 times smaller than the Sun, and half as cold, which makes the star a Teegarden close to a brown dwarf. The star is 12 light-years away, and has 2 confirmed planets orbiting it at a short distance. These 2 planets, TGC and B, both may be habitable. TGC and B are probably some of the closest size planets to Earth. TGSB is much closer to a dwarf. Its orbital period is only 5 days, while TGSC is 11 days. Both planets are blocked by waves. Despite how cold the central star is, TGSB has an equilibrium temperature of 82 degrees Fahrenheit, which is slightly higher than Earth's temperature of -1 degree Fahrenheit, but still fairly close. TGSC, on the other hand, has an equilibrium temperature of -52 degrees Fahrenheit, which, although smaller, is still close enough to Earth. What's interesting, a group of researchers led by Dr. Matthias Zeichmeister suggests that TGSB may be experiencing a strong greenhouse effect, which just raised its temperature. Nevertheless, given this and the similar amount of stellar fluxes received by Earth, both planets could support liquid water. TGC and B also probably have a similar earthy stone composition. It's also suggested they may have an entirely aqueous nature. Their atmospheres are unknown. However, it's thought that they may have weak magnetic fields delaying the erosion of the atmosphere by stellar winds. Exoplanet may have had stronger fields earlier, when the star may have still been active. But its strong flares and winds may have reduced the effectiveness of the fields. Nevertheless, scientists suggest that one of the TG's planets may be the habitable. Comes to the atmosphere being heated like Earth, since the central star is still capable of reproducing a habitable atmospheric envelope. Next in line is planet Ross 128b. It's one of the closest planets to our solar system. Ross 128b and its star only 11 light-years away from Earth. The star Ross 128 is a red dwarf, one of the least active nearby stars with a rotation period of 121 days. Recently, in 2017, scientists discovered Ross 128b using the HARPS instrument. They were able to determine that the exoplanet about 1.5 times the size of Earth and has an orbital period of 9 days. Therefore, it could probably be blocked by the tide. The exoplanet receives only 1.4 times as much energy from its star. Therefore, the temperature of Ross 128b can reach -76 to 80 degrees Fahrenheit. However, it's not yet possible to say for sure if the planet has water on it or if it's in the habitable zone. The planet is found to have an atmosphere. On the other hand, researchers believe that the exoplanet is very likely rocky. Moreover, it may contain a mixture of rock and iron. Also, a team of scientists, with lead author Diogo Swat, found traces of various elements important to life. On the star, carbon, oxygen, aluminum, calcium, potassium, etc. The researchers speculate that Ross 128b may have the same composition. Interestingly, Ross 128 may one day become the closest system to us, surpassing even the planetary system Proxima Centauri, which is about 4 light-years away. The point is that Ross 128 is getting closer to us, so in 79,000 years, it'll probably come very close to the solar system. Ross 128b has another interesting fact, this time related to alien life. Scientists at the City Institute studying signals from red dwarfs noticed strange repetitive signals with a frequency of 5 GHz coming from Ross 128. It didn't sound like interference, as there was no such signal from the other stars being studied at the time. However, listening to the star again later, scientists heard nothing. It turned out this unusual signal was probably coming from one of the geostationary satellites. Although we've not been able to detect alien life in the Ross 1280 system, its planet may be one of the most likely candidates for habitability. Hopefully, the next study of the exoplanet Ross 128b will be able to determine for sure if there's an atmosphere with water. Another exoplanet we want to tell you about is Wolf 1061c. This planet, together with its red dwarf star in the constellation of Ophiuchus, orbits only 14 light-years from Earth, making it the 5th closest system to us. The star Wolf 1061 is very dim and not very active, with a rotation period of probably 89 days. However, it has an interesting feature: it has high proper motion, meaning it moves quite fast in outer space. In addition to Wolf 1061c, the planetary system has 2 more super-Earths, Wolf 1061b and Wolf 1061d. However, they cannot possibly be suitable for life. The central star is about 1.8 times cooler than the Sun, so Wolf 1061d is very cold because of the long distance, and also could be a mini Neptune, while Wolf 1061b is very hot because of the powerful greenhouse effect, since it orbits at a distance of 3.5 million miles. Still, Wolf 1061c, being between the 2 planets, but close to the inner edge of the habitable zone, probably has good conditions for life. Wolf 1061c is more than 3 times the size of Earth. Moreover, its radius is also 1.6 times larger than our planet. Although it has a short rotation period of 18 days, so it may have a density close to Earth and could be a rocky exoplanet. However, because of its proximity to the star, Wolf 1061c may be blocked by tides. The planet also has a probable equilibrium temperature of -58 Fahrenheit, which is less than Earth's, but it may be enough to sustain water. Nevertheless, despite the rather optimistic predictions for Wolf 1061c's habitability, scientists believe the exoplanet may have living conditions similar to those of Venus. For example, astronomy professor Stephen Kane believes the eccentricity of the planet often becomes completely circular, so the orbit may for some time be completed in the Venusian zone, which leads to the disappearance of water and a Venus-like atmosphere. Although, on the other hand, the professor also says that when the planet's orbit changes back to almost elliptical, it can cool down, which means, given the likely difficult conditions on Wolf 1061c, it could be habitable and retain water. About 100 light-years away is the large-scale planetary system TOI 700. Like many systems on the list, the central star is a red dwarf, about 1.7 times cooler and about as much smaller as the Sun. The star TOI 700 is inactive, with a probable rotation period of 54 days. 4 confirmed planets from TOI 700b to TOI 700e orbit around it. All of them could likely be blocked by tides. Also, all of the exoplanet are slightly larger than Earth, with the exception of TOI 700e, which almost reaches the size of Earth. The inner planets of TOI 700b and c are unlikely to be inhabited. TOI 700b is possibly rocky, but most likely red-hot. TOI 700c, on the other hand, may be sub-Neptune, so it may be too cold for life to develop there. TOI 700d and are, in turn, a habitability zone. By the way, TOI 700e rotates before TOI 700d because it was not detected in the first studies. Both planets are probably in the joint resonance 4 to 3, and are likely rocky and may contain water. Moreover, TOI 700d may contain even more fractions of the open ocean than other exoplanets on which life is possible, such as Proxima Centauri b. The radii of both exoplanets are several times smaller than Earth's, 27e and 37 days, respectively. This may also hint at less powerful winds than on presumably some of the potentially habitable planets in the TRAPPIST-1 system. The question of atmospheres on the planets is still open. TOI 700b receives 35 times more stellar radiation than Earth, which probably could have damaged its atmosphere. However, scientists believe that the planet could still retain a dense atmosphere for billions of years. So TOI 700d could still have an Earth-like secondary atmosphere provided there is a magnetic field. Also, TOI 700d probably reflects a lot of sunlight, so it may be cooler than TOI 700e. Because of its recent discovery, TOI 700e has not yet been investigated in detail. However, it may hypothetically have a Venusian climate like Wolf 1061c. This planet has almost zero eccentricity, although the circular orbit may also mean the planet can maintain a stable climate and moderate surface conditions. It may also be able to change the elongation of its orbit, like Wolf 1061c, and therefore cool down while retaining water, but that remains to be seen. Still, for the moment, TOI 700e remains presumably inhabited, and only further observations will be able to give an exact answer. The last planet we'll tell you about is Gliese 73b, or Neptune b. It's located very close to us on the cosmic scale, 12 light-years from Earth. Neptune b is very similar to Earth in many characteristics. Thus, the exoplanet is 2 times larger than Earth and has an equilibrium temperature of 7 degrees Fahrenheit, which is very similar to the temperature of our planet. It also, along with the second discovered planet, Gliese 273c, orbits the red dwarf star 4 times smaller than the Sun, with a rotation period of 118 days, which makes it not very active. The exoplanet itself makes a complete revolution in 18 days. With such proximity to the star, planets tend to be blocked by tides. However, in the case of Neptune b, there is one peculiarity. Most likely, it may additionally be in resonance, that is, Neptune b may rotate alternating sides instead of heating only one. Given the temperature and the fact that the exoplanet is in the habitable zone, we can assume there's water there. Studies suggest that the planet may be a water world. Moreover, the exoplanet probably still experiences wave heating, meaning that it receives energy through resonance, which may also suggest the presence of water and the possibility of a biosphere. The composition of Neptune b has not been precisely established. It's believed that it may be either completely rocky or composed of 50/50 ice and rock. It's also not yet known whether the planet has an atmosphere, and only further research will help us find out for sure. Finally, there's another interesting fact about this system. In 2017, the METI Group, a separate part of SETI responsible for the search of extraterrestrial life, sent a radio message to the Neptune star and its planets. The radio signal contained a musical greeting and information on how to decode the signal. It'll take 12.5 years for the message to reach the potentially inhabited planets, so it will be a long time.